Welcome back to another video of subnetting. So this is Nirbhay, and in this video we will try to deep dive into concept of subnetting by taking some real life examples. But before starting, if you have not watched my previous two videos on IP addressing and first part of subnetting, so I highly recommend you to watch that video, because in the subnetting part 1 I have covered topics like IPv4 address structure, and we have understood what is subnetting with the help of classful versus classless IP addressing, and we understood what is subnetting by taking some analogies and different examples. And by taking a classful IP address, we found its subnet mask, network ID, broadcast ID and number of hosts, and we saw decimal to binary conversion and logical and truth table explanation that was required to find these values, and we saw how the things go if you are not doing subnetting and how subnetting actually help. So without wasting any time, let's get started. In this video, we will try to take a different IP range and we will put it on different interfaces, and we will derive it number of possible hosts, subnet IDs, subnet mask and broadcast IDs and many more things. And similarly, we will see it for if there is a requirement for larger host, and we will deep dive into concept of subnetting, and we will see every different aspects that are possible, and here we will deriving multiple subnet IDs, and at the last we will take two real-time different networking questions where we will take values from this previous section like subnet IDs or some random IPs, and we will further try to derive it different values like subnet mask, subnet ID and many more things. And while explaining these topics, I will be covering a major topic that is on AWS, like what to put on VPC CIDR range and how to derive multiple subnets from it. So if you are someone who want to go in cloud domain or in DevOps domain or anything related to networking, so this video is must for you. And by the end of this video, your concept towards subnetting will surely get cleared. Now let's move to our first example. Okay, now on my screen you can see I have taken two routers and there are four different interfaces that are attached to them. Okay, now let's say I want to connect 30 devices on interface 1 and 50 devices on interface 2, and let's say 20 devices on interface 3, and on interface 4 it will be always 2 devices because it is an interface between two routers, so it will be always 2 only. Okay, now what IP ranges should I select in order so that on interface 1 I can get this 30 devices connected or 50 devices or 20 or 2 devices connected? So either I can take IP addresses from different ranges. Let's say here I can take IP address from class A, and on interface B I can take IP address from class B, and similarly from class C, and again let's say from class C. Are this actually required? Because let's say if you take IP address from class A, so it will consist of around 65,000 IP addresses. Okay, but here required is only 30, means we will be using only 30 IPs from the 65,000 IPs and we will be wasting other IPs. So is this okay? I don't think so. Okay, similarly it will be for 50 also, and similarly it will be for 20 also, because by taking this much large IP it is not good idea. Okay, so what we can do, let me clear out this. And there is another important concept in subnetting, that is subnetting is done in two ways. That is, first it is done according to host, and second it is done according to network. Okay, and in our scenario there is requirement for different host, so means we are doing subnetting according to host. Okay, so there might be other condition like we want this many network, like this many subnets, so in that scenario it will be according to network, but currently we are covering according to host only. Okay, so in our scenario the maximum number of required host is 50 only. Okay, and if we sum up all the values it will not go beyond, let's say 100 also. Okay, and in class C, if you have watched my previous video, you know, like in class C maximum possible hosts are around 256, means in this we can take an IP address from class C also. So I will be taking an IP address from class C, so it will be, let's say 196.20.20.0. okay, so by default what will be its CIDR range? It will be /24, means first 3 octets are given to network, or first 24 bits are given to network, that you can see in red, which are represented by 1, means network bits are represented by 1 and host bits are represented by 0. Okay, now by looking in our architecture you have to find the max number of hosts that was required. Okay, so maximum number of hosts was it is 50 only, as other was 30, 20 and 2. Okay, so the 50 was the max host that was required. Okay, so we have to keep this in mind. Okay, in the first step we have to write our IP address as it is, that is 196.20.20.0. okay, where the first 3 octets are given to network as it is class C, you can see, and the last octet means last 8 bits are given to host. So in second step we have to write the decimal values that are given to network as it is, so it is 196.20.20, and for the host we have to write binary of it. Okay, so what will be the binary of 0? If you have watched my previous video, then you know it is 8 times 0. Okay, so like I quickly write it. Now in the third step, what you have to do, you have to find the value of n, and similarly we will be also finding the number of hosts that are possible. Okay, so what was the max number of hosts that was required? So it is 50. Okay, so we have to use the formula which is 2 raised to n minus 2, which should be greater than or equal to 50. Okay, so we have to satisfy this condition. Okay, so what we can put in the power n, so that after subtracting 2 also it will be greater than or equal to 50. Okay, so in this table if we take 32, so it is not greater than or equal to 50, so we have to take 64. So what its power? It is 2 raised to 6. Okay, so means our n will be 6, so it will be written something as 2 raised to 6 minus 2, okay, which will be 2 raised to 6 is 64 minus 2, which equals to 62 possible host. Okay, so we have find this value, number of host is 62, means these are the usable number of hosts and total host are 64 only. Okay, so why we are separating these two? So these are the first and the last IP of that range, means the subnet or network ID and the broadcast IPs. So n is equals to 6, it satisfies our condition which is 50. So n is equals to 6, it satisfies our condition which is greater than or equal to 50. Okay, now in step 4 what you have to do, you have to write again this conversion into binary as it is, which is 196.20.20.8 times 0. Okay, so let I quickly write this. Okay, now what you have to do, as our n value was 6, okay, so you have to take 6 bits from host from right to left. Okay, so what it will be till here. Okay, so this many bits will be still be given to host. Okay, and rest that is remaining, the 2 bits, now it will be given to network. So now as you know, the network bits are represented by 1 and host bits are represented by 0, as you can see in this also. Okay, so what we have to do, we have to write this decimal number as it is, which is 196.20.20, because in the class C the first 3 octets are given to network. So anything if you do AND operation with 111, it will be giving us that value only. So that's why the first 3 octets value we will be writing as it is, but in the fourth the subnetting is being done. Okay, means here only 6 bits we are taking for host and 2 bits we are giving to network. Okay, so if you are giving to network, then what it will be? It will be 1 1 and rest it will be 0 0 only. Okay, now you can see this will be total of 8 digit, it will be of total different 8 digit. Okay, and here also these are total 8 different digit. Okay, and now if we write their values, so it will be 128 64 32 16 8 4 2 1, as you can see here also, like 2 raised to 7, which is actually the 8 bit, but as it is starting from 0, that is 2 raised to 0, and it is going to 2 raised to 7, means total 8 different digits are there, means total different 8 bits are there here on. So here only your subnetting is being done. So how it is done? So as you have already given some number of bits from host to network, means the network has borrowed some bits from host, so this is only known as subnetting. Okay, so now we will write its decimal values, which is 196.20.20, and the number of bits that are given to network is, that is 2 raised to 7 and 2 raised to 6. If we sum up this both, that is 128 plus 164, so it will give us 192. So we have to write this. Okay, and in fifth step, what we have to do, we have to find its subnet mask. Okay, we have to find it subnet mask. So by default, the subnet mask for class C is what? It is 255.255.255.0. It is actually the representation of the bits that are given to network. Means here you can see in class C all the first 3 octets are ones. Okay, and all ones in decimal are represented by 255 and all zeros are represented by 0. Okay, so this is the by default subnet mask for class C. So if the CIDR is with /24, then its by default value will be this 255.255.255.0. but here some bits from host are now given to network also. Okay, so then what will be our subnet mask? So we have to write the first 3 bits that are given to network as it is. So it will be 255.255.255. okay, and the last subnetting is been done, means some bits are given to network. Okay, so how many bits are given to network? It is 128 plus 64, that is 192. So we have to write it again. So that will be our subnet mask. Now in step 6, we have to find what will be our first subnet ID. So the first subnet ID will be similar to the network ID itself. So it is our network ID. Okay, so then first subnet ID will be similar to this only. So it will be 196.20.20.0. but here 24 bits are given to network. But in our scenario, how many bits are given to network? So the first 3 octets, means the first 24 bits are given to network plus 2 more bits are given to network, means 24 plus 2, that is 26 bits are given to network. So what will be our CIDR range? It will be /26. okay, now what will be our subnet mask? So subnet mask will be, as it denotes, how many bits are given to network and how many bits are given to host. Okay, so in class C we already know the first 3 octets are given to network itself only. So we will be writing 255.255.255, and in 4 octet some bits are given to network. So how many bits? The 2 bits, and in decimal it is represented by 192. So it will be its subnet mask. Okay, this was its first subnet ID. So now what will be the second subnet ID for this? Okay, so what will be the second subnet ID for this? So in order to find the second subnet ID, you have to find the value of first network bit that is given from host to network. So as we see, these 6 bits are given to host. Okay, and rest 2 are given to network, means this is the first value that is given to network from host. And what will be its value? So it will be 2 raised to 6, because the last one will be 2 raised to 7, 6, 5, 4, 3, 2, 1 and 0. Okay, so what will be the power of 2 raised to 6? So it is 64 only. Okay, as we have already written here. So it is 64. Okay, so what will be our second subnet ID? So we have to write the bits that are given to network as it is. So it will be 196.20.20, and now we have to keep on adding this value that we have find. So it was 64. So our second subnet will be 196.20.20.64/26, and similarly what will be our third subnet? So it will be 196.20.20, and we have to again add the 64 to it. So it will be 128/26. So what will be our fourth subnet? It will be 196.20.20, and again we have to add 64 to it. So it will be 192/26. Now what will be the broadcast IP for this first subnet? Okay, so if we see the total, usable IP for this range, okay, so it is 64. Okay, so it will start from 192.20.20.0, and means from 0 it will go up till 63. Okay, so as it is going up till 63, so our first IP was always network ID or subnet ID, and our last IP was always, so our broadcast IP will be 196 .20.20.63. okay, so as now we have defined 4 different subnets, so now we can allot it to different network interfaces. Let's say the first subnet will go for interface 1, and second subnet will go for interface 2, and third subnet will go for interface 3, and similarly fourth will go for interface 4. Now we will taking example of an architecture when there is a larger requirement of host. Okay, so let's say on interface 1 I required 200 devices, on interface 2 let's say I required 512 IPs, and let's say here on 300, and interface 4 it will be always 2 only. Okay, so now for demo we will be taking an IP from class A, that is 14.0.0. by default its CIDR range will be /8 only. Okay, so in the first step as usual we will write IP address as it is, that is 14.0.0. okay, and in the second step what we have to do, we have to write the bits that are given to network as it is, and other we have to write their value, and for other we have to write their binary value. Okay, so in class A the only first octet or the first 8 bits are given to network and rest are given to host, means rest 24 bits are given to host. Okay, so I will be writing 14 as it is, and 0 8 times 0, okay, dot 8 times zeros, dot 8 times zeros. Now before proceeding with our third step we have to identify the number of hosts that was max in our given architecture. Okay, so which was the max number of hosts that was required, so it is 512 only. Okay, so here in step 3 we will be finding the value of n and the number of usable host. Okay, so we will be finding these two values. Okay, so what we have to do, we have to again satisfy this condition by using this formula 2 raised to n minus 2, that should be greater than or equal to 512, because our requirement is 512. By taking what value it will actually satisfy this condition. Okay, so in the table 2 raised to 7 it's 128, means in this table the maximum value we are taken is till 2 raised to 7 only, means for 2 raised to 8 the value will be 256, because it is just getting doubled, and for power of 9 it will be 512. Okay, but can we take this 512 here, because if we take the value of n as 9 also, and it will give us 512, and if we subtract this 2 then it will give us 510 only. Okay, that is from 512 minus 2 it will give us 512, but it will not satisfy our condition, that is we required minimum of 512 hosts. So now we have to anyhow take the next major possible value, that is with the power of 10, so it will be around 1024. So we have to take this only. So now if we take 2 raised to 10 minus 2, so it will give us 1024 minus 2, that is 1022 number of usable host. Okay, number of usable host it will be. Now the value of n is 10 only. Now in step 4 we have what we have to do, we have to again write this decimal and binary value as it is, means 14 that is given to network, and again its binary value as it is. So it is 678.45678.1234567 okay. Now what was the value of n, means how many bits are given to host. Okay, so we are giving 10 bits to host, so we have to come from right and take those 10 bits for host. Okay, so for the last, as we know, each octet will consist of maximum 8 bits, so it will be for host, and we have to take 2 more bits from this third octet, means till here we are taking this is 8 and again 2, and rest it will be given to network, means the first octet, the second octet, and from third octet some bits will be given to network. So what the network bits are usually represented as 111. Okay, so I will be just replacing them all with 1. Okay, here also 1 1 1 1 and 1. Okay, so now if we see the value, what the value will be this for 1, so it will be 128, again 64, 32, 16, 8, 4, 2 and 1. Okay, now we have to calculate the sum of the bits that are given to network, means we have to exclude this last 2. So if we sum up the value of all powers, means from 128 till 1, so it will be giving us total as 255. Okay, so we don't want the last two values, means we don't want this 2 and 1, so means 255 minus 3, it will give us 252. Okay, so now we have to write its decimal value. Okay, so what will be the decimal value? It will be 14, and all ones in decimal are written as 255, and in third octet as subnetting is being done. Okay, so in decimal it will be written as 252, and the last bit are all for host, so it will be 0, as all are 0 only. In fifth step, what will be the subnet mask for this IP? Okay, so by default for class A the subnet mask is 255.0.0.0 because only the first octets or the first 8 bits are given to network. Okay, but here some subnetting is done in third octet. So in class A you already know the first octet is given to network and all ones are represented with 255, and but here subnetting is done, so second octet are also given to network. Okay, so again all ones means 255 will be written, and in third octet some bits are given to network, means if we sum up all this it is giving us 252. So in decimal it is 252, and the last octet is for host only. Okay, so we have to write 0 as it is. Okay, now what will be the first subnet ID for this? So the first subnet ID is always almost similar to its network ID only. So what was its network ID? It is 14.0.0.0/8. It was network ID. Okay, so what will be the first subnet ID? It will be also like 14.0.0.0, but here by default 8 bits are given to network, that is okay, but apart from that you can see more 8 bits are given to network, and here 6 more bits are given to network, means 8 plus 8 16, and 16 plus 6 means 22 bits are given to network. So what it will be? CIDR range, as CIDR range denotes the how many bits are given to network. Okay, so here 22 bits are given to network. So what will be its subnet mask? Okay, so it is basically the how many bits are given to network and how many bits are given to host. Okay, so in class A always the first 8 bits are given to network, means all ones is 255, and second octet means second 8 bits are also given to network, means again 255. Okay, and from third octet some bits are given to network, and if we sum up their values, so it is giving us 252, so it will be 252, and the last it is given to host, means it will be 0 only. Okay, so now what will be the second subnet ID? So to find the second subnet ID, first we have to write its n value, so which was n is equals to 10, as we have already seen. Okay, now in class C, as we have seen, when we are finding the second subnet value, we were taking the value of the network bit which was firstly given from the host to network, so it was 64. Okay, which was 2⁶, and its value was 64. So similarly we have to identify the first value of network bit that is given from host to network. Okay, so what was that value? Okay, so as first 10 bits are reserved for our host. Okay, and you can see that is 2�0 and 2�1 and 2�3, means this value was given to network, means this value was the first value that was given to network from host. So what is power? It is 2�2, means 2�2, which gives us value as 4. So we have to keep this value in mind. Okay, so what will be our actual subnet? Okay, so we have to write again the value that are given to network as it is. Okay, so in our example 14 was given to network, and as we have given another 8 bits to network, so we will write 0 again as it is. Now in the third our subnetting is done, means some bits are given to network. Okay, so we have to increment that value by using this number. Okay, we have identified the first network bit value that was given to network from host. Okay, so which was 4. So our second subnet will become 14.0.4.0/22. So this will be our second subnet. So what will be its subnet mask? So it will be, so it is basically the number of bits that are given to network and number of bits given to host. So it will be 255, as first bits always belong to network in class A, and second 8 bits we are given to network by ourselves, and in third if we calculate this total sum, so it will give us 252. Okay, and last octet it is given to host. Okay, so this will be a subnet mask for this subnet ID. Okay, now what will be the third subnet ID? So again we have to keep on adding 4, so it will be 4.0.8.0/22. So by taking this example, basically I wanted to show you where you have to actually change the bit in which octet to get your next subnet IDs. Okay, so now you know in whichever octet you are doing subnetting, in that octet only you have to change that bits. Okay, so now we will be taking one more example, and with the help of this we will try to resolve these two questions. Okay, so let's say on interface 1 I want 30 devices, and on interface 2 I want 58 devices, and on interface 3 again I want 40, 20, and let's say here I want 2. So I am taking here IP again from class A, that is 14.0.0.0/8. Okay, so what we have to do, again we have to write that IP again as it is. So I will be writing 14.0.0.0. Okay, so in the second step what we have to do, we have to write again the bits that are given to network as it is. So 14 is given to network, and for host we have to write their binary values. So it is 8 times zeros, okay, again 8 times zeros, okay, again 8 times 0. Okay, and in the third step what we will know, we will be finding the value of n, and we will be finding the value of number of usable hosts, okay, as well as the number of total hosts. So before proceeding with this, we have to identify the max number of hosts that is being required. Okay, so in our state it is 58, as rest other are smaller only. Okay, so we have to again satisfy this condition, that is 2 raised to n minus 2, which should be greater than or equal to 58. Okay, and in our scenario again what is the best value that satisfy the condition? So it is 64, because if we take 32 it will be less than 58. So we have to anyhow take this 6 as n value. Okay, so it will be 2 raised to 6 minus 2, which equals to 64 minus 2, which will give us 62, that are actual number of hosts that are being usable. So n is equals to 6. This satisfy our condition, that is greater than or equal to 58. Okay, so in the fourth step again we have to write this binary values as it is with its network bits value. So 14 dot again 8 times 0 dot 3 4 5 6 7 8 dot 1 3 4 5 6. So now we have to give the value of n to the host. Okay, so how many value we have to give? We have to give 6 bits, that is still here. Okay, and rest we have to give to network. So I will be simply writing this first network bit as it is, and I will be simply making all as 1.4. okay, and here 2 more bits are there. Okay, so in decimal if I write, it will be 14.255.255. So what will be the value for this? It will be 2 raised to 7 and 2 raised to 6, will be 128 plus 64, which will give us 192. Okay, so this will be the decimal value for this. Okay, now we have done the subnetting in the fourth part. Okay, so in the fifth part again we will find the subnet mask. Okay, so what will be the subnet mask? So by default the subnet mask for this class A is 255.0.0.0, but here we have done subnetting, so the first bit are given to network, means 255, and second we have ourselves given to network, so means again 255, and in the third also we have given to network, so again 255, and in the last some bits are given to network and their addition is 192. So we have to write 192 as it is. Okay, so what will be its first subnet ID? So it will be always similar to its network ID, so which is 14.0.0.0/8. Okay, so we have to write it 14.0.0.0, but here 8 bits are given to network, but in our scenario the first 8 bits and then again 8 bits and then again 8 means 24 bits plus 2 more bits are given to network, so it will be 26. So it will be /26. Okay, so what will be subnet mask? So it will be 255 as we have given to network, and again 255 again for network, and again 255 as third bit also is given to network, and for fourth subnetting is being done, means the addition of this means 128 plus 64, it will give us 192. So this was the subnet mask. So to find the second subnet ID, what we have to do, we have to again find the first network bits value that are given from host to network. Okay, so what was the first network bit value that was given from host to network? So it is this value only, means 2 raised to 6, which equals to 64. Okay, so what will be our second subnet? It will be 14.0.0, and as our subnetting is being done is 4th octet. Okay, so we have to keep adding value in 4th octet. So it will be 64/26, and similarly for third subnet it will be 14, it will be 14.0.0.128/26. fourth subnet will be 14.0.0.192/26. and what will be the fifth subnet? So you may be assuming that it will be 14.0.0. if we add 64 again here, so it will give us 256. Okay, so which is not correct. Like in an octet it can have maximum of bit as 255. So what will happen? Okay, so as I have shown you example also, like in a second it consists of 60 second, which will range from 0 to 59. Okay, but it will be of 60 only. Okay, so after 59 this 0 will become 1, that is 1 minute, and this will become 00. So similarly, instead of this 56, what will happen? This will become 14.0.1.0/26, and it will go on, and at a time will come, it will become 2, and then will become 0, and it will keep on going. So now let's say someone asks what will be its second last subnet ID. Okay, so we know like this IP was its last subnet ID. This is the last subnet. Okay, so let me write it once again. That is 14.255.255.192. So now as we have seen the example, okay, so second last subnet ID will be just an subnet before this subnet. Okay, so how our subnet is being incremented? It is incremented by 64. Okay, so our second last subnet ID will be after subtracting 64 from this 192. So it will be 14.255.255.128. So this will be our second last subnet ID. Okay, so now what will be our broadcast ID for this first subnet? Okay, so again, as it is second subnet ID is starting from 14.0.0.64, so our broadcast IP will be just an IP before this IP. Okay, so it will be 14.0.0.63, because in the actual usable IPs also it is starting from 14.0.0.1 till it will go to 62. This will be the actual usable IPs, and this will be the network or subnet ID. Okay, and this will be the broadcast. So I'm hoping you are clear with this. So as we have derived many subnets, okay, so we can give this subnet on any interface. Let's say for interface 1 we can give this, on second subnet we can give to interface 2, and similarly for third and fourth and so on, like how many 5-6 interfaces are there, so we can give them. Okay, so now as I have told earlier in this video, I will be resolving that one major doubt that is related to cloud or related to DevOps. Okay, so if you are someone that is working in AWS, okay, and you are creating VPC, or let's say you are from Azure, you are creating VNet. Okay, so you want to assign CIDR range to it. So what actually that value will be? So what actually that value will be, that we will be inserting that. Okay, so let's say I am writing here. So let's say I am writing here VPC CIDR and subnet 1 and subnet 2. Okay, so what I will be taking this value in CIDR and what value I will be taking in subnet. Okay, so either what you can do, you can take this value as CIDR, that is 14.0.0.0/8 as a CIDR, and this subnets you can take at under subnets, that is 14.0.0.0/26, and again this 14.0.0.64/26. So if your requirement is something like that, you want minimum 58 hosts within each subnet, so you can either go in this way. So in this scenario, the total host possible in this VPC will be around 65,000. Okay, but in the subnet, maximum possible usable host will be around 62 only. Okay, so let's say you don't want to provide this much host space for your VPC. Okay, and you want to provide, let's say, 62 or 64 only. Okay, so what you can do, you can take this subnet as your CIDR range. So it will be 14.0.0.0/26, means in your VPC now you can have maximum of total 64 hosts. Okay, and suppose you want to create subnet of different range, and let's say on first subnet you want 40 different hosts, and for subnet 2 you want 20 different hosts. So this is possible with the help of another advanced topic of subnetting, that is VLSM. So if you want me to make the video on this, so please do comment in the comment section. Okay, so now let's move to our next practical questions. Okay. So in the first question, let's say I am taking an example of IP address, or it is actually a subnet ID itself. Okay, so from the previous example you can see we have derived different subnet ID. So the first one was 14.0.0.0/26, and the second one was 14.0.0.64/26. okay, so I have taken that subnet ID itself, okay, as a IP. Okay, now what we have to do, we have to find is subnet mask, what will the subnet ID, and what will the number of host, and like a host range, broadcast IP, and so on. So by just looking at this IP, what we know, this belongs to class A, and in class A the first octets or the first 8 bits are given to networks. So what we will do, firstly we will write its IP address as it is, that is 14.0.0.64. okay, now as per the class A, we will write the bits that are given to network as it is, that is 14, and rest that are given to host in binary, that is 0000.4.123.4.234 times 0. Okay, now here already subnetting is been done, means 26 bits are given to network, means from 32 26 are given to network, means 4 plus 2 means 6 are given to host, 6 bits are given to host. So we have to again take those 6 bits for host, that is from here till here it will be for host, and rest all we are making at 1. okay, so 1 2 3 4 5 6 7 1 2 3 4 5, and here 2 bits are given to network. So in order to find the subnet mask, how we actually find? So subnet mask, basically it is the decimal value, that is representation of how many bits are given to network and how many bits are given to host. Okay, so by default subnet mask for class A was 255.0.0.0, but here subnetting is already done. So what will be the next subnet mask? It will be 255, as the first is given to network only, that is 14, okay, which is by default, and second and third octet also we are given to network, again 255 and 255, but in fourth octet subnetting is being done. Okay, so what will be the value for this 11, which will be 128 plus 64, so it will give us 192. So our subnet mask will be 255.255.255.192. okay, now what will be the subnet ID? Okay, so here given is 64. okay, so how actually we can verify whether it is a correct subnet ID or not? So to find the subnet ID, or you can say network ID, so to find the subnet ID, basically this is an AND operation between this subnet mask and the given IP. Okay, so if you do the AND operation between this 255 with any other IP, so it will give you that IP only, means as the first 3 octets are 255, so we can easily write the first 3 bits as it is, that is 14.0.0. okay, but the last bit is something different, means it is 192, and here it is 64. So suppose what could have been our network ID if we have not done that subnetting? So it could be simpler, 14 dot, because we write the network ID as it is. Okay, because anything we do AND operation with network ID with IP, that will result with that value only, which will 14, and by default other 3 octets were 0, and so anything we do AND operation with 0, it will result in 0 only. So if the subnetting was not done, means if it was with /8 only, so it could be something this subnet ID, but here the subnetting is been done, it is /26. so what could be our subnet ID? So as we seen, anything we do AND operation with 255, it will result with that value only. Okay, so we have to write 14 as it is. Okay, and rest 2 bits also, because here also 255 is there, so means AND with 0, it will give us 0 only, and again AND with 255, it will give us 0 only. Okay, now in the 4th octet we have some other value, that is 192. Now suppose if we do AND operation by opening your calculator and clicking on these 3 lines and selecting programmer, and here suppose I write 64 and drop down this bitwise and select AND and type 192 and click on equal. So you can see we are getting value as 64 only. Okay, so our subnet ID will be 14.0.0.64 only with CIDR notation as 26, because 26 bits are given to host. So our subnet ID become 14.0.0.64/26. Okay, so what are the number of usable host? Okay, so this is the subnet ID, means it is the first ID. Okay, so what will be the next subnet ID? Okay, so how we can note? So as we have seen, for host, how many number of bits are given? 6 bits are given. Okay, so 2 raised to power of 6 means it gives 64 hosts, like total 64 hosts are possible. Okay, and among them, if we use this formula again, 2 raised to n minus 2 is equals to 2 raised to 6 minus 2, which give us 64 minus 2, which will give us 62 total usable host. Okay, so the number of total usable host becomes 62. Okay, now we want to get the usable host range. Okay, so as the IP range start from 14.0.0.64, so the next subnet ID will become what? It will be 14.0.0.128/26. So now what will the actual usable host range? So from this we got 62 as usable host and 64 as total host. Okay, so our range will range from 14.0.0.64. This will be our first, that is subnet ID. Okay, so our usable host range will start from 65 and it will go up to where, as our next subnet ID is starting from, if we add 64 more into this, it will be 14.0.0.128. okay, /26. Okay, so our broadcast IP will be just one IP before that, so it will be 14. We got that our broadcast IP also, so it will be 14.0.0, just one IP before this, it will be 127. Okay, so as this is our last IP, so our total actual usable host range will start from 65 till 126. So it will be of total 62 IPs. Okay, so this will be our total usable host range, that is 140.0.0.65, and it will range till 126. So this will be our actual usable host range. So now in question 2, I have taken some random IP, that is 14.0.0.66/26. So now we have to confirm whether it is a valid subnet ID. We have to find its subnet mask, subnet ID, number of usable host and usable host range, and what will be its broadcast IP. Okay, so as you can see, 14.0.0.66, it is somewhere coming in between this range that we have provided, that is usable range, that is from 65 till 126. Okay, so in question 2, I have taken a random IP. Okay, now we have to find whether it is a valid subnet ID. We have to find its subnet mask, subnet ID, number of usable host and usable host range and its broadcast IP. Okay, so as we have done this previous example, okay, so you can see 14.0.0.66/26. so this is not an subnet ID, this is basically an IP that comes in this range for this subnet, that is for 14.0.0.64/26. so it is the part of this subnet, but we know. So suppose you have not performed this question and you have not done this whole thing, so how could you directly answer whether it is a valid subnet ID or not, on how could you find all these values? Okay, so as usual, in the first step, what we have to do, we have to write that IP again. So it is 14.0.0.66. okay, and in the second we have to write the binary of the bits that are given to host. Okay, so the first bit, it is given to network, so it will be 14 dot again 8 times zeros. Okay, and again 8 times zeros, and again 8 times zeros. So from the IP we know that 26 bits are given to network, means 32 minus 26 is equals to pending 6 bits are given to host. So we have to take 6 bits from here, that is, so in a shortcut way what you can do, you can directly write 14, and as we have given 26 bits to network, means here 8 bits and again 8 and again 8, so it will be 8 plus 8 16 and 24. So you can directly write 1111 over here, and here the value will be 2 raised to 7, means 128 plus 64. So it will be 11 and again all zeros. Okay, so to write in decimal value, so what we can do, we can write bits that are given to network. So to write in decimal, we can always write the first bit of A, that is 14, and the bit that are given to network. Either here you can derive its decimal value, like you have to again write its network bits as it is, and you can directly skip this step, like you can take the shortcut, like you already know, like 26 bits are given to network. Okay, so first means 8 bits and rest also 16 bits will be given to network, and if it is given to network, then all bits will be represented by 1. Okay, and in decimal it will be written as 255, so you can directly write 255 for the second and third octet. Okay, and for the fourth, as we have done subnetting here, okay, so its value will become 128 plus 64, which will give us, so subnet mask basically is the value that denotes how many bits are given to network and how many bits are given to host. Okay, so by default the subnet mask is 255.0.0.0, but for this, as subnetting is being done, so to find the subnet mask, we already know like 26 bits are given to network. Okay, so 26 bits means like first 3 octets are given to network only, means it will of 24 bits. Okay, so we can directly write 255.255.255, as we can also see from here, this is for network, this is for network, this is for network, and in the fourth octet subnetting is being done. So what value we have to write here, it is the sum of these values that are given to network from host, so it will be 192. Okay, so we found this subnet mask. So now we will find its subnet ID, and if we got value different than this, so we can say it is not a valid subnet ID. Okay, so in order to find subnet ID, logically what we need to do, we need to perform AND operation between this subnet mask and the given IP. Okay, so as we know, anything we do AND operation with 255 will result with that value only. Okay, so as we have 3 octets with 255, so we can write the 3 octets with 255 as it, means those bits are given to network. Okay, so we can write those values as it is, that is 14.0.0, and for last we have to again open our calculator, again click on this 3-line programmer, and here we have to write 66, drop down this bitwise and click on and write 192 over here. Okay, so what value we are getting, it's 64. So means its subnet ID is 14.0.0.64/26, as 26 bits are given to host. So by looking to this subnet ID, we can say this is not a valid subnet ID. Okay, so we have found our subnet ID. Now we have to find number of usable host. So how we can find the number of usable host? Like we know how many bits are given to host, so it is 6 bits. Okay, so number of usable host will be 2 raised to n minus 2, so it will be 2 raised to 6 minus 2, it will be 64 minus 2, which equals to 62 usable host. Okay, so usable host was 62. Okay, let's I write this subnet ID also. which is 14.0.0 plus 6.64/26. Subnet mask was 255.255.255.192. Sorry for my handwriting, but it is like that only. And usable host range will be like, as our IP are increasing by 64, as we know, like total 64 IPs are there and 62 are usable. Okay, this was total and this was usable. So next subnet ID would be 14.0.0.128/26. Okay, so our IP address just before this 128 will be 127. Okay, so which will be 14.0.0. So this IP basically is an last IP, which is also known as broadcast IP. So we found again broadcast IP first, that is 14.0.0.127. okay, so what will be the actual usable host range? So IP ranges between the network or subnet ID and between this broadcast IP. So it will range from where 14.0.0.65, where it will go, it will range till 126. So this is the usable host range. So this is all about subnetting according to host. So in the next video I will be covering subnetting according to network. So there are differences would be like, here we are doing subnetting as per the host requirement, like we want 50 hosts or 60 hosts. Okay, so there like difference would be, we want 2 networks, 4 networks, or let's say 500 networks. So there will be like that. So that will be a shorter video only, because we already have covered most of the things of subnetting. So there I will be taking max 1 or 2 example and I will be completing this basic subnetting part. So if you think I have explained you the subnetting in a better way, so you can simply like, subscribe and comment in the comment section if you have any doubt. If you don't have any doubt, still you can comment in the comment section how you feel about this video, what can be improved. Till now, see you in next video.